Well, thank you all. That was really illuminating. We have time for questions. Hold up your hand, and there's a question. Who's got the mic? John is coming with it over to that corner. We'll get you, okay, we'll get you next.
One of the arguments against solar variability being responsible for recent increases in temperature is that the greenhouse gas models predict that the stratosphere will actually cool while the lower troposphere warms. And experimental observations seem to bear that out, whereas there's no reason to expect stratospheric cooling if it's a solar influence. Is there a ready answer for that argument?
Essentially, there's a very clear answer on that. These are the kind of stuff that is called a strategic session in Aspen by Stephen Schneider, Al Gore, and all those guys. The short answer is that, first of all, you got to look carefully into the lower stratosphere's temperature. Most of it is dominated by volcano signal and ENSO. If you look into the chunk, you will clearly see that it's hard to prove. But the main part of it is also that depends on how the energy budget in the lower stratosphere is being controlled. It's actually controlled by wave heating from below, actually. Don't get fooled by them. There's not much atmosphere in the air in the first place, okay? And the UV is interacting with the ozone, so the ozone field is important. So some of the warming, cooling trend is actually related to the ozone decreasing slowly. But it has nothing to do with the sun not being able to do this because the sun radiation just passes through. And then I can show you one example. For example, one counter example is that if you study the climate model production, there's one model exists where you quadruple the CO2. Guess what happened to the lower stratosphere? It's not cooling. It's actually warming because the excessive heating from the active troposphere, where they put all the planetary wave height started to heat up this level. So it doesn't fit. Okay.
Thank you, Willie. Next question over here.
Oh. Hi, Willie, could you bring up that slide with Gavin Schmidt's pictures on the left-hand side?
That will be the AD people, but please, what's the point?
Okay, the question is, I think the lower slide has a picture of a graph from chapter 10 of AR5, which is 10.1, and that Gavin Schmidt is talking about the reliability of the models. Mm-hmm. Well, that graph has the models projections below versus it's on the temperature, time temperature versus time. So the models are a level line pretty much, and then the observations are higher. The temperatures are higher than what the models show. And the argument then is that the result between the observations and the models is greenhouse gases, okay? Now, if you can play with the models using adjustment of parameters to make the model line come wherever you want, then on what grounds can you say, can they say that I think,
Larry, I understand your question now. I'll try to explain to the audience. Larry is describing how the model was saying that if you put in natural forcing, you do this, and then Fred Singer showed that. But I have to tell you, those are tricks. I actually have another presentation that shows you that if you study what the individual climate models, there's about 36 of them, but they make multiple runs, so it run up to about 100 some scenario. If you do that, you will see that the model values, which I'm just trying to inform you, they adjust everything. The value can go from 10 degrees Celsius, then you compare with the observation, it doesn't look that impressive anymore because they do a difference of an anomaly, so they collapse out the curve and then the curve looks very nicely behaving. I mean, this is why presentation tricks is one of the key things that they have been able to achieve this amazing craziness.
Tomorrow morning, I'm going to show a single slide that I suspect you'll all be drawing on cocktail napkins for the rest of your life to display the difference of the argument we just heard of really what describing junk science is and how if you choose your data correctly, you can prove absolutely anything. Where's the next question?
Yeah, we
Okay.
have time for one more question, but I just wanted to let
Yeah.
you guys know that there's snacks in the exhibit hall as well as beverages, and then the next panel will meet at 4:15, so we're going to try to get back on schedule. But there will be a 15-minute breaks with snacks and things like that, so.
Looking at all of the data you guys have been presenting, it seems to concentrate on total solar incidents. But my understanding is when we have solar flares and things like that we have energy going out into other frequencies. And I'd be interested to know what the energy going into different wavelengths away from the light wavelengths is affecting our atmosphere and our climate.
Sebastian, you want to take that one?
Yeah, so often, absolutely right, people are just calculating with TSI and then they say, well, this change is not enough to drive any climate. And this is probably really the case, that TSI is not enough. We have also seen there is still calibration problems. But what we are probably dealing with is solar amplifiers. And one is a stratosphere, so there are research teams out there and they are looking at the ultraviolet radiation. And there's really good progress. When you look at the temperature in the stratosphere, there are papers that show over the solar cycle, 11 years, there is a couple of degrees of change in temperature. And there's now also models how this temperature comes down from the stratosphere into the troposphere. And this is not included in any of these models. So this link between stratosphere and troposphere. Another one, of course, is the Svensk-Mark effect. This is still being debated, and there is pros and cons, but there's still papers coming out that cloud distribution in a more complex way, probably than previously thought, is controlled by solar activity and the cosmic rays. So these two amplifiers would be my favorite candidates. And this is why I also showed the solar magnetic field and not the TSI, and you can probably also translate that, but it's maybe really the magnetic field that controls somehow the cosmic rays and so forth. So TSI alone is not the answer to the question.
Well, I'm going to conclude.
I'm going to do an
go ahead.
advertisement. There is a sitting world expert on charging and hence nucleation of aerosols sitting in our audience. His name is Professor Fang Kuan Yu, formerly from UCLA, but now at Stony State University of Albany. He's the world expert on this topic, really. So do chat with him.
Find
Thank
him
you.
later. I'll conclude where we started. It is the sun, stupid. Thank you all.
Very much. Thank you. Very good. Thanks. We all agree on that.